Hello students, in this video I Abhay Kumar going to discuss an important topic in current electricity, which is Owen's bridge for B.Sc Part 2 Physics courses in lecture number 6 of current electricity. Owen's bridge is a sensitive bridge for the measurement of inductance, that is self-inductance capital L, in terms of resistance and a standard capacitance. The construction of Owen bridge is similar to a Wheatstone bridge, which consists of four resistances in four arms. Similar to a Wheatstone bridge, Owen bridge consists of also four arms: AB, BC, CD, and AD. The inductance, that is self-inductance capital L, whose value is to be calculated, is connected in series to a variable resistance capital R3 in branch or in the arm AD of the bridge, while in arm AB of the bridge a variable resistance R1, capital R1, is connected in series with a capacitor C1, while in arm BC only a capacitor of capacitance C2 is connected, while in the fourth arm CD of the bridge a resistance capital R4 is connected, which is a fixed resistance. A headphone is connected in the diagonal arm, that is between points B and D of the bridge. Now at the balance point, we have Z1 upon Z2, where Z1 is the impedance, that is total resistance of arm AB of the Owen bridge, while Z2 is the impedance or resistance of arm BC of the bridge. So Z1 by Z2 is equal to Z3 upon Z4. Z3 is the total resistance of arm AD of the bridge, while Z4 is the resistance of arm CD of the bridge, that is Owen bridge. So at the balance point we have Z1 upon Z2 is equal to Z3 upon Z3, and this balance condition is similar to the condition of equilibrium of a Wheatstone bridge, which is R1 by R2 is equal to R3 upon R4. Suppose it is equation number 1. Now impedance of arm AB of the bridge is given by Z1 is equal to R1, which is a variable resistor, capital R1 is, plus 1 upon J omega C1, which is the inductive reactance of the capacitor C1. It is Z1, that is total resistance of arm AB. And Z2 is equals to 1 upon J omega C2. In the second arm, that is in arm BC of the Owen bridge, only a capacitor C1 is connected. So Z2 is equal to 1 by J omega C2, and Z3 is the impedance of the third arm, that is arm AD of the Owen bridge, in which an inductor of inductance capital L is connected in series with a variable resistor R3. The value of inductance capital L of this inductor we have to calculate it. So Z3 is equal to R3 plus 1 upon R3 plus R3 plus L omega J omega L, which is the inductive reactance. J omega L omega is the inductive reactance of the inductor, and here operator J is used. Now we have Z4 is equal to, finally Z4 equals to R4, that is impedance of the fourth arm CD of the Owen bridge. Only a resistor of resistance R4 is connected. तो ओवन ब्रिज के फोर्थ आर्म में केवल एक रेजिस्टेंस है, इसलिए फोर्थ आर्म CD का इम्पिडेंस R4 के इक्वल होगा. नाउ substituting these values, that is values of Z1, Z2, Z3 and Z4 in equation 1, which is the balance condition, which is Z1 by Z2 is equal to Z3 by Z4 of the balance condition of the Owen's bridge. Say it is equation number 2. All values Z1, Z2, Z3 and Z4 are taken as in form of equation 2. Now using equations 2 in 1, so using 2 in 1, we have using 2 in 1, we have Z1 is R1 plus 1 upon J omega C1 upon Z2 is equal to 1 by J omega C2 equals to Z3. Z3 is R3 plus J omega L upon Z4 is R4. Now from equation 2 we have R1 plus 1 by J omega C1 multiplied by J omega C2 equals to R3 plus J omega L upon R4. इक्वेशन 2 के LHS में डिनोमिनेटर में टर्म प्रेजेंट है 1 by J omega C2, hence J omega C2 will be multiplied in the numerator. तो चूंकि इक्वेशन 2 के डिनोमिनेटर में टर्म 1 by J omega C2 प्रेजेंट है, इसलिए टर्म J omega C2 न्यूमरेटर में मल्टीप्लाई हो जाएगा. नाउ वी हैव, अब ब्रैकेट को हटा दिया जाए तो ब्रैकेट के अंदर बोथ टर्म्स R1, फर्स्ट टर्म R1 एंड सेकेंड टर्म 1 by J omega C1 को मल्टीप्लाई करना होगा ब्रैकेट के बाहर टर्म J omega C2 से. तो नाउ मल्टीप्लाइंग R1 by J omega C2, वी हैव J omega R1 into C2 plus, after multiplying 1 by J omega C1 and J omega C2, J omega in the denominator and numerator will cancel out. So we will left with 1 by C1 multiplied by C2, that is C2 plus C2 upon C1. ब्रैकेट के अंदर सेकेंड टर्म 1 अपॉन जे ओमेगा C1 है, तो ब्रैकेट हटाने के बाद ब्रैकेट के बाहर टर्म आउटसाइड द ब्रैकेट टर्म जे ओमेगा C2 से मल्टीप्लाई करना होगा. तो मल्टीप्लाई करने पर जे ओमेगा डिनोमिनेटर एंड जे ओमेगा न्यूमरेटर में कैंसिल हो जाएगा. तो सेकेंड टर्म में अब C2 अपॉन C1 एंड RHS can be written as R3 by R4, R3 upon R4 plus J omega L upon R4. RHS को RHS में टर्म है R3 plus J omega L upon R4, तो इसे रिप्रेजेंट किया जा सकता है. वी कैन राइट इट एज R3 upon R4 plus J omega L upon R4. Say it is equation number 3. Now equating real and imaginary parts, that is equating real terms and imaginary terms in both sides of equation 3. Equating real and imaginary parts of equation 3, imaginary terms or parts of equation 3 in both sides of equation 3. Equating real and imaginary parts in both sides of equation 3, we get equation 3 के LHS में रियल पार्ट RHS में रियल पार्ट के इक्वल होगा. तो इक्वेशन 3 में रियल पार्ट इज C2 by C1, देयरफॉर C2 अपॉन C1 इक्वल्स टू real part in RHS of equation 3 is R3 upon R4, R3 upon R4, therefore C2 upon C1 is equal to R3 upon R4, and we have obtained this condition given by equation number 4. And equating the imaginary terms in both sides, that is LHS and RHS of equation 3, we get J omega R1 C2 is equal to J omega L upon R4. Therefore, J omega and J omega in LHS and RHS will cancel out. So, we will left with R1 C2 equals to, in LHS R1 C2 and in RHS we have L upon R4, capital L upon R4. And with the help of, suppose it is equation number 5, from equation 5, we have L is equal to R1 R4 multiplied by C2, and with the help of equation number 6, that is L, capital L is equal to R1 R4 multiplied by C2, we can calculate the self inductance capital L of the inductor joined in the third arm AD of the Owen's bridge. Condition 4 can be satisfied by adjusting the variable register of resistance R3, while condition 6 can be satisfied by adjusting the variable register of resistance capital R1 in the branch AB of the Owen bridge. And with the help of equation 6, which is capital L, that is self inductance of the inductor, equals to R1 multiplied by R2 multiplied by C2, that is we have obtained the inductance or self inductance in terms of the variable register of resistance R1, a fixed resistance R4 and a fixed capacitor of capacitance C2. Now this video is completed. Thanks all of you for watching my YouTube channel Physics Quantum Classes. यदि यह वीडियो आप सभी को पसंद आया हो तो इस वीडियो को अधिक से अधिक लाइक करें तथा मेरे यूट्यूब चैनल फिजिक्स क्वांटम क्लासेस को भी अधिक से अधिक नंबर्स में सब्सक्राइब करें